Subclaim B for geometry then continues the work of subclaim A, but has a little bit of an application focus. Remember we talked about that subclaim A for geometry included all of this congruence and similarity. And so basically subclaim B is then doing stuff with that, working with transformations. I'm using those transformations in the congruence and similarity work, but here this is, this would be supporting content. Understanding what's going on with the transformations then leads to my more success with the congruence and similarity. Geometric constructions comes up, and I would encourage you to look at some examples of those from illustrated mathematics, and then geometric formulas and applying properties and theorems. This gets into not just geometry in the sense of kind of pure geometry, but it also has a Cartesian coordinate system, analytic geometry kind of a connotation, because you'll see that it includes completing the square to find the center and radius of a circle given by an equation. And so this is kind of the marriage of some of that algebra work they've been doing in Algebra 1 with quadratics, and then we bring it to bear on circles and equations of circles. So it's that application of not only things that they've been doing in geometry, but also things they did in Algebra 1. And so it's really important when kids come to you that you have a strong sense of what they've done in Algebra 1 that you can build on. Then subclaim B for Algebra 2 focuses on this marriage of what they're doing in functions with the statistics. And by the way, subclaim B for Algebra 2 is rather full, if you will. We're not only going to interpret functions and find equivalent expressions for the content from subclaim A for Algebra 2, but we're also going to, again, perform transformations on functions. We're going to work with the unit circle with trigonometry, and then solving systems. And there is a large portion of subclaim B for Algebra 2 that focuses on the statistics and probability, including univariate and bivariate data, inference, and probability. So, excuse me, as kids come to you in Algebra 2, if they've gone through the Common Core, they will have a solid foundation in linear and quadratics. We take that to other function families, as we talked about in subclaim B, but then we also build on that content of the statistics and probability in branching out into this real data analysis, fitting functions. So we're going to use those exponential and trigonometric functions and fit them to data to solve contextual problems, make inferences, and then certainly apply some of those frequency tables and probability and some of the probability rules, like the addition rule. So subclaim B in Algebra 2 is actually almost bigger, if you will, than subclaim A. And I would say it's a lot more additional content than maybe Algebra 1 and geometry. So that's an important, if you teach Algebra 2, you really want to take a look at this subclaim B and make sure you're getting students to a higher level of thinking with that. Now, if you are worried about the content of your courses, you may want to hit pause right now and spend some time looking at subclaims A and B to make sure the content is included in your courses. Because as we look at subclaims C and D, things change kind of focus areas. We're moving not away from content, but it's a different lens through which to look. So if you want to hit pause and spend some time with subclaims A and B, that might be a good strategy, and then start the presentation with my next slide of subclaim C. All right, subclaim C then, and this subclaim is common with all tested grades and courses in terms of this is all about reasoning. There's a couple important points to make before we dig into the tables specifically for each end of course test. Is that this is about taking the content from subclaims A and B and doing stuff with it. Making viable arguments about a solution method, critiquing the reasoning of others. An important thing is this is the critiquing the reasoning of others and not critiquing the procedure of others. It may involve looking at their procedure, but what I see too often, especially in high school mathematics classes, that when we look at other people's work, we're really focused on, well, they did this algorithm wrong or they factored wrong. What this is about is really choosing appropriate solution methods. Why did you choose to factor that rather than graph it to find the zeros? Why did you choose to put it in slope-intercept form rather than point-slope form to find out information about this linear function, and so on? So this is an important thing to look for as you look at the focus of the content. So this is about not just the content, but then what we're doing with that content. So let's look at some examples and some highlights. Before we dig into this table in detail, I want to make an important distinction from what we have looked at before. On the left-hand side, you will see these references to these abbreviations. These are not from the Common Core standards. These are from the Blueprints document. And the Blueprints document includes this area C, they call it, that gives details about the type of reasoning problems that will be given. So you want to have that out at this point if you don't, or in the future for that matter, when you look at this. So when you look at this, you're not going to go find a high school category C in your standards. You're going to find that in the Blueprints document. So the other thing to know as we look at these performance level descriptors for subclaim C is that there is some commonality between the three courses, but there's also some differences. So it's important to see that we're valuing reasoning in all three courses, but we might be reasoning about different content. We might be picking out different parts of the same content, and we'll see that here in just a minute. So for instance, you see that regardless of my level here for this first bullet, that I need to create responses based on the principle that the graph of an equation is the set of all its solutions. I teach a lot of high school, I've taught a lot of high school kids over the years, including some I taught last year, where kids leave Algebra 1 and they still struggle with that concept. So that's a principle that is going to permeate the solution methods required of kids regardless of their level of attainment. So again, reasoning about linear and exponential growth, and so on and so forth. So you see here that these are the types of reasoning that will be required for student responses. Other items of note then is you'll see as you dig into subclaim C for Algebra 1 that the amount of logical reasoning that I use will increase as my performance level goes up. An important thing to note, and this cuts across all three courses for subclaim C, is that you can still pass the test and have some minor calculation errors. That will give you pause as you meet as a high school mathematics department to really discuss partial credit when you grade regular summative assessments, as well as the types of items you give kids. So that's an important distinction. You can perform at a level 3 with minor calculation errors. Level 4 requires performing precise calculations and using correct grade level vocabulary. So the moral of the story is you do not have to be perfect in your mathematical communication and your calculations to pass the test for reasoning. Now, you still have to know the content. But what they're doing is saying that a minor calculation error is not going to cause you to fail the test. And I think that's an important distinction that maybe some high school math teachers will have to wrestle with. So Algebra 1, subclaim C, really focuses on the reasoning with functions, being able to justify a conclusion, and then providing a counterexample if they have a disagreement with some reasoning that's presented. So that's a different flavor than maybe we've traditionally had in Algebra 1. Okay, geometry subclaim C then obviously is going to look at this chain of reasoning about not just geometric propositions and conjectures, but algebraic. So there's some function work that happens in geometry that kids will have to reason for, or reason through, rather. And then certainly, given the bulk of the work in geometry being about transformations and congruence and similarity, the reasoning component is hand in glove here. And you see that the change in student performance from level to level involves the use of more vocabulary, correct computations, and then certainly the level of sophistication of the justification. Now, that is a process, especially in geometry, that kids are going to have to work toward. And this whole idea about reasoning and proof is a developmental process that you'll want to maybe even be very structured with at the beginning of the school year and gradually wean kids off to be more independent in their reasoning and their creation of those chains of reasoning.